Okay, so this is problem number 13-10. So what's given is there's a block that's 20 pounds weight, and it is attached with a string to another block that's 80 pounds, and this with the force P, we're pushing this 80-pound block so that this block is moving to the right with an acceleration of 6 feet per second square, and we're asked to find the force P. Okay, given the acceleration, given the coefficient of friction is 0.4 on this table. Let's first draw the free body diagram. Okay. So here's the free body diagram. So first let's draw the free body diagram of, maybe we should draw the free body diagram of the smaller block. Okay. The 20-pound block. Okay. I'll just call this block A. Okay. Block A, block B. So on the block A, so if this body is moving towards the right with an acceleration of 6 feet per second squared, then that means this is also going down with 6 feet per second square, right? So because it's one continuous, it's tied with a thread. So however this moves, this will also move. So the body is 20 pounds, right, which is acting down. The tension going away from the body is T. Okay, and here the acceleration, this one is going down, acceleration, right, because the top one is moving towards the right, so this should be going down. If the acceleration for this body is going down, then inertial force MA would be up, always opposite to the direction of acceleration, MA. Now let's just do the let's just do some of the forces. There's nothing in the horizontal direction, so everything is vertical. I'm going to consider up as positive, down as negative. So T minus 20 plus MA is equal to 0. So T equals 20 minus mass is, MA is, we need to find the mass, which is the weight divided by acceleration, 32.2. This is the mass part times A, right? And that acceleration is 6 feet per second square. So let me go ahead and put that. So what do we get? We get T as 16.273 pounds. Alright, so the feet per second square from here will cancel out with the feet per second square from here, and 20 is pounds, so this 20 is also pounds, so everything here would be pounds. Okay, and that makes sense because tension is measured in pounds. Now let's do the free body diagram for the block B. Okay, so of course there's an external force P. The body is moving with a acceleration in this direction, so the inertial force for this would be MA would be in this direction, right? Now the tension, again going away from the body is moving towards the right, so the frictional force would be towards the left, which is again mu K times the reaction force, right? Mu K times the reaction force. I'll just call that frictional force, I'll say F equals mu K times the weight of the body in this case, okay, which is, I'll just say N, which is the reaction force, Okay, here, let's call that N. Okay, so this gives the entire frictional force. Right, now all we got to do is put it together in sum of x equal to 0 formula. Anything to the right I'm going to say is positive, anything to the left is negative. Now what do we have? P is going to the right, so that's positive, plus T also going to the right is positive. F is going to the left, so that would be negative F. That's the frictional force. And we have what else? MA, of course. MA, right, to the left, so equal to 0. Now P we need to find. T we already found, 16.273. F is this 0.4 times the weight. There is no other vertical force, so the reaction is just the weight, right? So the action is this 80 pounds, and the reaction is would be the same. So N is equal to 80. So times 80, and so here if I have to, so this is this, this is this, this is this, and then MA, we're going to write that, minus mass is what, 80 divided by 32.2 times acceleration is 6. Okay, that's a given. Okay, this point I'd like to elaborate again. The force, so the frictional force, let me write, frictional force is the coefficient of friction times the reaction force. In this case, N is equal to 80 because there's only one vertical force. In the previous problems we had many vertical forces, and sum of all of that was equal to N. The you know, positive, negative, whatever it was, all of it was equal to N. But in this case there's only one force acting down, which is the weight, right? So N is also 80 pounds, which we have used here. Okay, so when you put all of this together, when you calculate, you get, let me see, okay, so you get 30.63 pounds. Okay,